So this is going to be the first part for chapter 10 on the muscular system. If you guys like this page, please be sure to subscribe. Please let your friends know, let everybody know about this. Let your classmates know, let your professor know. Perhaps your professor wants to share it also with whoever your instructor is. They may want to share it with their other students as well in some of their other classes or other sections, as well as their colleagues. Please be sure to leave me some feedback. If you have any questions, send me an email directly. You can find that information in the comment section below. You can send me an message through YouTube. Please be sure to like my Facebook page. I'm going to leave a link in the description below as well. And again, the other thing I'm going to try to do a little bit differently in this chapter is that now this is going to be a pretty long chapter. It's going to be very memory intensive. There's over 600 muscles in this body, in our body actually, in the human body. We have over 600 muscles. So yeah, I don't think anybody's going to end up memorizing all 600 muscles. But we're going to try to get through as much as we can. And then what I'm going to do is that probably I will make some kind of an exam review. And that exam review will cover muscles that I think will probably be on exams that most of you will be taking. So please be sure to look out for that one. That should be up probably by, it'll be up by the end of this of this chapter of this series. I think there might be 3 parts to this chapter. I'm not sure, but be sure to look out for it. Again, when you subscribe, be sure you set alerts on so when the exam review is up, when new material gets posted, you guys will be aware that the material is there. Okay, so muscle tissue is made up of all contractile tissues. We know about this already because this is what we learned in chapter 9. And remember the 3 different types of muscle tissues that we have. We have skeletal muscle, which you find attached to all the bones. We have cardiac muscle, which you only find in the heart. And we have smooth muscle, which we find lining your visceral organs. Now, this chapter we're going to be looking at skeletal muscle, and we're going to look at how muscles they interact to bring about movement. So in other words, how are we able to move our arm away from our body? How are we able to lift books up? We're also going to look at how muscles are named. What are the criteria that are used for naming the muscles? Also, we're going to be learning about the principles of leverage, which somewhat ties in with how muscles interact. These 2 things kind of go hand in hand together. So we're going to be looking at all these things, and then of course we're also going to be looking at the different muscles in our body and how we name them. Now, something that's very important to understand is that muscles, they can only pull. Muscles, they never push. So what one muscle group does, another undoes. And so I want you to think about this. When you're lifting up something, for example, a book, or you push and then you're putting a book down, don't think that, when you're lifting the book up, your muscles actually, your muscles pulling at that point, which is true. But then don't think that when you're putting the book back down, that your muscles pushing your arm down. That's not the case. Muscles, they never push. They're always pulling. And the way that they achieve this is that muscle groups, they work together. So what one muscle group does, another group of muscles, it undoes. So we have 4 functional groups of muscles, and we're going to be looking at these 4 groups now. So the first functional group of muscles that we look at are what's called these agonists or prime movers, and this is the main muscle that's responsible for producing a specific movement. Then you have this antagonist. Okay, an antagonist, this is muscle that opposes or it reverses a particular movement. Now, prime movers and antagonists, they're located on opposite sides of the joints across which they act upon. So, for example, when you look at, again, let's just take the example of your forearm, when you're bending your forearm upwards. So, now, when you're doing that, the muscle that's contracting, the muscle that's pulling your forearm up, that's going to be your bicep muscle, all right? And the muscle that's allowing you to lower your arm back down, that's going to be your tricep muscle. So your bicep is located anteriorly, and your tricep is located posteriorly. All right. So again, these muscles are located on opposite sides. One's located in the front, the other's located in the back. And again, so what happens is when you want to, when you lift up your arm, your forearm, your bicep contracts. So when it contracts, it's pulling up your forearm. Now, to lower your arm again, what ends up happening is your bicep relaxes, but that's not enough. What also needs to happen is your tricep, it needs to contract. So when your tricep contracts, it lowers your forearm. All right. So again, these muscles, they're working together and they're having the opposite effects. So in this case that I just I told you. Now, two muscles, they can both be an agonist and an antagonist. So the example I just gave you, when you lift up your forearm, when you're bending your forearm upwards, you're pulling it upwards, the bicep is acting as your agonist and your tricep is acting as an antagonist. Now in the opposite movement, okay, when you're lowering your forearm, at that point, your tricep is acting as the agonist and your bicep is acting as the antagonist. Synergists, these are muscles that help the prime mover by doing one of two things. Sometimes they add a little bit of more extra force to the same movement, or they can be reducing some undesirable or unnecessary movement that could occur as your prime mover contracts. Now, fixators, these are synergists that immobilize a bone or a muscle's origin so that the prime mover has a stable base on which they can work upon. Going back to this motion, when we're pulling our forearm up, now keep in mind the bones. So the bones that we're working with right now are your humerus. Okay, your humerus, remember, it attaches to your scapula, right? The glenoid cavity of the scapula, and then so your bicep muscle, it's attaching itself to the radius, and that's the bone that's moving. So it's the bicep muscle. It inserts into the radius, and the origin of the bicep muscle is going to be your humerus. Okay, at the head of the humerus. Now keep in mind that the joint, however, that's your humerus is the glenohumeral joint. So what that means is that your scapula, it's going to be moving as well. Okay, because remember, the scapula is not held by any other bone; it's being held by muscles. So when you're bending your arm, muscles need to fixate that scapula, so you're able to, pull up your forearm without your entire upper arm shaking and moving about. So those fixators, we have specifically your trapezius and rhombus muscles. Now these are the fixators. So this stabilizes this joint and it allows your biceps to contract so you can smoothly bend your forearm upwards. Okay, so keep that in mind. This is what this fixator is doing. This is why these are very important. And at that same joint, when you're looking at Synergist, so your biceps brachii, these are the prime movers. So the synergists, the muscles that are helping these biceps brachii, are the brachialis. So the brachialis, they lie deep to the biceps brachii, and these are the synergists. They help the prime mover. So when you look at this illustration here, they have the pectoralis major muscle that they're showing here, and what they're showing you here is the flexion of your humerus. So the two muscles that we're going to be looking at, the agonist and antagonist, this is the agonist, the pectoralis major, and this is going to cause the flexion movement. And the antagonist is going to be your latissimus dorsi. So the latissimus dorsi, it causes the opposite movement. It's going to allow you for extension of this humerus. So this illustration here shows you your deltoid muscle. And what they're showing you is that when the deltoid muscle contracts, it causes an abduction of your humerus. Okay, so your arms are moving upwards away from your body. So imagine a child, he lifts his arm upwards and he's pretending, his arms are wings of an airplane and he's running around pretending he's an airplane. So the muscle that allows a child to do that are these deltoid muscles. Okay, it's specifically the middle fibers of the deltoid muscles. Now, for the opposite motion, okay, when you want to bring your arms back downwards, back towards the midline of your body, then the antagonist for the deltoids will be your teres major muscle. Okay, so the teres major is going to be your antagonist, and this allows adduction of your humerus. Some muscles may be prime movers of one movement and antagonists of a different movement, and it could be a synergist of a third movement. So I kind of gave an example of this before. So when you think about, again, when you're flexing your forearm up, the prime mover is going to be your biceps brachii, and the antagonist is going to be your triceps. But on the opposite, okay, when you're you're extending your forearm back downwards, then that prime mover is going to be your tricep, and then the antagonist is going to be the bicep. This is all that they're referring to over here. Now let's look at how skeletal muscles are named. Now keep in mind that there's a number of different criteria that's used to name these skeletal muscles, but if you pay attention to some of these criteria, it'll help it make it a little bit easier for you to memorize these muscles, and also know, if you're reading about it, where they may be located, and again, why they're named the way that they are. So again, these are important things to learn now to help learning the names of these later on. So the first thing that we're going to be looking at is that, when we look at some of the names of these muscles, it indicates the bone or the body region in which the muscle is associated with. So the example that they give you over here is this temporal bone. So this temporalis muscle, it overlies this temporal bone. Another example it can be your intercostal muscles. Now these intercostal muscles, they run between your ribs, okay, or your costals. So inter is between, and costals ribs. So between the ribs, intercostal muscles. Now, some muscles, they're named for their shape. Now, muscles, they have distinctive shapes. So, for example, when you look at the deltoid muscle, it's almost like it's triangular shape. So when you look at deltoid means triangle. So you have this triangle-shaped muscle, deltoid. In addition to that, there's another muscle that's on your back. It has a shape of like a trapezoid, so they call it the trapezius muscle. And this trapezius muscle, we already know what your deltoid muscle does. The trapezius muscle, it's a muscle that allows you to look to move your head upwards. So if you're at a circus and you're looking at, those people that are running across the rope, the muscle that you use to look upwards is your trapezius muscle. The next thing we're going to be looking at is the size of the muscle. So terms such as maximus, minimus, or longus, or brevis, this is often used to refer to the size of the muscle. So for example, when you're looking at like your gluteus maximus, gluteus minimus, these are the large gluteal muscles. So these are the large muscles of your butt. The names of some muscles reveals the direction in which their fibers and fascicles run in reference to some imaginary line. Usually this is the midline of the body or the longitudinal axis of a limb or a bone. So when you see the term rectus, you're talking about fibers that are running parallel, that are running straight to that imaginary line. When you see transversus, you're talking about fibers that are running at a 90-degree angle to that imaginary line. And then when you see the term oblique, you're talking about fibers that are running at an angle to that imaginary line. So when you see the terms biceps or triceps or quadriceps, it's talking about the number of heads or the number of origin the number of origins the muscle has. So for example, the example that we used earlier, your biceps brachii muscle, that biceps brachii, it has two origins, okay, 2 points of origin, two heads. Some muscles are named according to their points of origin and insertion. Now, the origin is always named first. So when you look at the example here, the sternocleidomastoid, this is one of the muscles of your neck. And this muscle, it has dual origins. So the one of them is on the sternum and the other is on the clavicle. This is how we get sternocleido, okay, sternocleido. And then it has the mastoid process of your temporal bone as the insertion point. Okay, so two origins, your sternum and clavicle, and then the insertion is on the mastoid process. So sternocleidomastoid. When muscles are named for the movements they produce, action words such as flexor, extensor, adductor, abductor appear in the muscle's name. Now, sometimes several criteria can be combined to name the muscle. So for example, this muscle here, this extensor carpi radialis longus muscle. Okay, extensor carpi radialis longus. So when you look at this, the criteria that's being used is, first of all, when you look at extensor, we're talking about action. Then we're talking about when you see the terms carpi and radialis, we're talking about location. Okay, so extensor carpi, and then longus, we're talking about size. So three criteria are used to name this muscle: extensor, carpi, radialis, longus. So while all skeletal muscles consist of fascicles, and if you guys think back to the previous chapter, fascicles is another term that we use to describe bundles of fiber. What's different is the arrangement of these fascicles. They vary and they result in muscles with different shapes and functional capabilities. And the most common patterns of these fascicle arrangements that we see, they're circular, convergent, parallel, and pennate. And we're going to be looking at each one of these individually now. In this illustration, you can see in this picture right here, the circular fascicle arrangement. Then over here, you see this fusiform arrangement. This is convergent. This is a parallel. This is a multipennate. This would be a bipennate. And this is a unipennate. Now let's look at these in detail. So when you have a circular fascicle arrangement, the fascicles, they're arranged in these concentric rings. So the perfect example is this orbicularis oris muscle. So this is the muscle over here that forms your mouth, orbicularis oris. So when these fascicles, when they constrict, the opening closes. Okay, when it relaxes, the opening can open. The general terms that we use to refer to these circular muscles are sphincters. So the other place that we find it, aside from this orbicularis oris, would be around your eyes. So like you have these orbicularis oculi. In addition to that, you find them in there that make up your external sphincter muscle of the anus. So again, during the process of defecation, when these muscles relax, you're able to defecate. A convergent muscle has a broad origin, and its fascicles, they converge towards a single tendon of insertion. Such a muscle is triangular or fan-shaped, like that of your pectoralis major muscle of your anterior thorax. So here's another picture of this circular, the muscle that's arranged in these concentric rings. So again, this is an example of this, orbicularis oris. And then we're going to be looking at this muscle next, which is a type of a convergent. So what you can see is these fascicles, they end up converging to this single tendon over here. So all these guys are coming here, this way, to this single point. So this is a convergent fascicle arrangement. And again, if you look at it, this is kind of like a fan-shaped that you end up getting with this convergent arrangement. Next, we talk about this parallel fascicle arrangement. So in a parallel arrangement, the long axis of the fascicles, they run parallel to the long axis of the muscle. Now, such muscles are either strap-like, as we have in the sartorius muscle of your thigh, or they can also be this spindle-shaped, as we do in your biceps brachii. Now, in this book, we differentiate this. So when the muscle is just in this spindle-shaped that we get, but still having this parallel fiber arrangements, we call it fusiform, okay? If it's not in the spindle shape, but again, the fascicles are running parallel to the long axis, and they're strap-like, then we call them parallel, okay? So these are, some people, some anatomists, they considered fusiform to be part of parallel. Others, they differentiated. So in this book, they're differentiating parallel from fusiform. And this is solely based on the shape that you get of the muscle. So when you have this spindle shaped, and then the fibers are still running parallel, we call it fusiform. When you just have these this non-spindle shaped, these fascicles that are running parallel to the long axis in these strap-like appearance, then we call it parallel fascicle arrangement. So if you look over here, so again, this is your biceps brachii. So if you look over here, you've got this spindle shape. These two, first of all, they're running parallel, but then notice, they how it kind of spindle out to this in this form over here. It's unlike what you're going to be looking at over here for the sartorius muscle, which is more of a strap-like. So then, this would be this perfect example of this parallel. So if you look over here, there it goes, your sartorius muscle. Notice how they're just, nice and parallel over here. So this is this parallel arrangement, and then this is your fusiform arrangement over here. In a pennate pattern, the fascicles, they're short and they attach obliquely to a central tendon that runs the length of the muscle. Now, if the fascicle inserts into only one side of the tendon, then we say that the muscle is unipennate. So the example of this is this extensor digitorum longus muscle. If the fascicles insert into the tendon from opposite sides, so the muscle's grain resembles a feather, then we say the arrangement is bipennate. Now, the rectus femoris of the thigh is a bipennate muscle. Now, for a multipennate arrangement, This looks like many feathers that are situated side by side with all the quills inserted into one large tendon. The deltoid muscle, which forms the roundness of the shoulder, is an example of a multipennate fascicle arrangement. So here's an example of this multipennate fascicle arrangement. So again, this is a deltoid muscle. So if you look over here, it looks like several feathers, and they're all coming. They all end up coming. Their quills ended up inserting to a single tendon over here. So this is an example of multipennate fascicle arrangement. So in this example here, you can see that the fascicles are inserting into the tendons from opposite sides. And again, this is an example of this rectus femoris muscle, and this is a bipennate fascicle arrangement. So what we're looking at over here in this image is that the fascicles, they're inserting into only one side of the tendon. So in this example of this unipennate fascicle arrangement, and we're looking at this extensor digitorum longus muscle. So as we've seen, the most common patterns are the circular, convergent, parallel, fusiform, and pennate fascicle arrangements. The arrangement of the muscle's fascicles, it determines its range of motion and its power. Because the skeletal muscle fibers may shorten to about 70% of their resting length when they contract, the longer and more nearly parallel the muscle fibers are to the muscle's long axis, the more the muscles can shorten. Muscle power depends on the total number of muscle fibers in the muscle. The greater the number of muscle fibers, the greater the power. So when you look at these bipennate and multipennate muscles, they pack in a lot of muscle fibers. However, they shorten very little. But because they have so many muscle fibers, they're still very powerful. Now we're going to be looking at the lever systems in our body. So this is the bone-muscle relationship. So the operation of most skeletal muscles, it involves the use of a leverage and lever system. And again, this is a partnership between the muscular and skeletal system. A lever is a rigid bar that moves on a fixed point called a fulcrum when the force is applied to it. Now, the applied force or effort is used to move a resistance or a load. In your body, your joints are the fulcrum and your bones, they act as the lever. Muscle contraction, it provides the effort which is applied at the muscle's insertion point on a bone. The load is the bone itself, along with the overlying tissue and anything else you're trying to move with that lever. A lever allows a given effort to move a heavier load or to move a load farther or faster than it otherwise could. If the load is close to the fulcrum and the effort is applied far from the fulcrum, a small effort exerted over a relatively large distance can be used to move a larger load over a small distance. Now, such a lever is said to operate at a mechanical advantage and is commonly called a power lever. When you're looking at this picture over here, with the example that we just spoke about, so let's look at what's happening over here. So you have the load, which is close to the fulcrum, but the effort is far away from So when you look at this picture over here, the load is close to the fulcrum, and the effort that's applied is far from the fulcrum. So in other words, you have this long handlebar over here, okay? The handlebar is far away from the fulcrum. And the effort, okay, remember, your muscle pushing down, it's very easy for you to do. You have to apply little effort. In other words, your muscles apply a little bit effort in order to easily move this car up, okay? So again, this is what they're saying when they say this is a mechanical advantage, okay, or power advantage. The load is closer to the fulcrum with effort being farther from the fulcrum. So imagine if this was not the case. Now imagine if this lever was very short, okay? In other words, if the lever is right over here. Think about how hard it would be for you to push this up. So typically speaking, again, another way if you want to look at it. So imagine you're at home and you're trying to open up a bolt that's attached to a wall. So you take a wrench out, and you attach the wrench, and you're turning it. You're trying to turn it actually. You're trying to turn that bolt, but it won't turn. It's just too hard, and you're pulling with all your might, but you still can't do it. So then you call a friend of yours over, and your friend comes over. He brings a very, very long wrench, and he's able to easily, even with minimal effort, he's able to turn that bolt. Okay, so what you end up having is this. You're just increasing the distance from where the effort is being applied to the fulcrum. So the longer this distance is, okay, the less effort you have to apply to move the load. On the other hand, if the load is far from the fulcrum and the effort is applied near the fulcrum, the force that's exerted by the muscle, it has to be greater than the load to be moved or supported. And we say that this type of lever system operates at a mechanical disadvantage, and we term this a speed lever. Now these levers, these speed levers, they're useful because they allow the load to be moved rapidly over a larger distance. So when you look over here at this example, notice how far the fulcrum is from the load. The fulcrum is very far away from the load, and the effort is very close to the load. So the amount of energy that has to be used, the effort has to be far greater than that of the load over here. Okay, so the good thing about this is that you can quickly move the load, and you have this wide range of motion that you're going to be able to apply. So that's the plus side. The negative is that it requires a lot of energy. So if you look over here, we're going to compare this to the previous picture that we saw. So again, over here, so notice when the distance between the fulcrum and the load is very far, okay, and the distance between the fulcrum, and then you're going to look at the distance between the effort and the fulcrum, it's close. So what happens is the amount of energy that you need to use is going to be far greater. So look at this. You need to apply 100 kilograms of energy in order to move 50 kilograms of load. Now, when you compare it to this photo over here, this is where we have a mechanical advantage. Now notice what we have here. We're moving, the load is 1,000 kilograms, okay? So in order to move 1,000 kilograms of a load, only 10 kilograms of effort is applied. So what's the main difference here is that the distance between the effort and the fulcrum it's far greater, okay? So a very long distance between the fulcrum and the effort. In addition to that, more importantly, from the effort to the load. So the distance between the fulcrum and the load, that is also, which is referred to as the load arm, it's also it's short. So the big picture is this. When the effort distance from the fulcrum is greater than the load distance from the fulcrum, the effort will be less than the load to be moved. When the load distance to the fulcrum is greater than the effort distance to the fulcrum, the effort that's going to be needed will be greater than the load. Depending on the relative position of the three elements, effort, fulcrum, and load, levers, they belong to one of three classes. In first-class levers, the effort is applied at one end of the lever, and the load is applied at the other. The fulcrum is somewhere in between. Seesaws and scissors, these are examples of first-class levers. So here you see the effort is at one end, and the load is at the other end, and somewhere in the middle you have the fulcrum. And the same goes over here. The effort is over here, where you put your fingers inside the scissors, and then the part that's being cut is going to be where the load is at. And the fulcrum is usually where the two blades are held together. That's going to be where the fulcrum is. So in your body, when there's another first-class lever system that you can see over here, when you raise your head off your chest. So the posterior neck muscles over here, they provide the effort at this atlanto-occipital joint. Remember, you have the occipital condyles and the atlas of your first cervical vertebrae where they articulate. That's that joint. So this is the fulcrum, and the weight that needs to be lifted, or the load, is the bones of your facial skeleton. So again, this is also an example of a first-class lever. In a second-class lever, the effort is applied at one end of the lever, and the fulcrum is located at the other, with the load somewhere in between them. And a wheelbarrow demonstrates this type of lever system. Now, while second-class systems, they're uncommon in the body, the best example that we do have in our body is when we're standing on our toes. All the second-class levers that we have in our body, they work at a mechanical advantage because the muscle insertion is always farther from the fulcrum than the load is. While second-class levers are known to be levers of strength, their speed and range of motion are sacrificed in order to get that strength. So this illustration demonstrates the load being between the fulcrum and the effort. So when you look at the wheelbarrow, the fulcrum is the wheel, the effort is the part where you're lifting up the wheelbarrow, the arms of the wheelbarrow, and the load is going to be the body or the cavity of the wheelbarrow where the load is carried. This illustration is also showing you the second-class lever. So when we're standing up on our toes, the effort is exerted by your calf muscles. The load is the weight of your body, and the fulcrum is this ball of your foot. In third-class levers, the effort is applied between the load and the fulcrum. Now, these levers are speedy, but they always operate at a mechanical disadvantage. Tweezers or forceps, they provide this type of leverage. Also, most of the skeletal muscles of your body, they act as third-class lever systems. So an example is the activity of your bicep muscle, lifting the distal forearm, anything that's carried in your hand. Third-class lever systems, they permit a muscle to be inserted very close to the joint across which movement occurs. This allows rapid, extensive movements with relatively little shortening of the muscle. The muscles that are involved in third-class lever, they tend to be thicker and more powerful. So this is illustrating third-class lever systems, and you can see that the effort is applied between the lever and the fulcrum. So again, this picture over here, they're showing you an example of a tweezer. You have the load on one end, and then you have the effort, which is in the middle, where you're going to be squeezing it, where your fingers are going to be squeezing on this end, and then you have your fulcrum, which is the part that the two ends of these forceps being held by, which is the fulcrum. So flexing the forearm by the biceps brachii muscle exemplifies this third-class lever system in the body. So the effort is exerted on the proximal radius of the forearm, the fulcrum is the elbow joint, and the load is the hand and the distal end of the forearm. In summary of the lever systems, we've learned that differences in the positioning of the three elements modifies the muscle activity with respect to the speed of contraction, the range of movement, and the weight of the load that can be lifted. In lever systems that operate at a mechanical disadvantage, these speed levers, the force is lost but speed and range of movement are gained. And in systems that operate at a mechanical advantage, these power levers, they tend to be slower, more stable, and they're used where strength is a priority. So our body has over 600 muscles, and a lot of them they're grouped by function and their location. In this course, with this book that we're working with right now, we're not going to be looking at all 600. We're going to be looking about roughly 125 of the muscles. Uh, Now, the muscle tables that's included in the text, it's going to give you the following information. The description, which includes the location relative to the other muscles, origin and insertion, and usually, again, you're going to find this spanning between a joint. Um, Also, it'll give you the information about the action of the muscle, so the movement that the contraction will cause. And in addition to that, you're going to see innervations. Usually, again, it'll give you information of major nerves that supply the muscle. Now, as far as tips goes for learning the names of these muscle, so first thing is make sure you know what you're reading. Okay, be aware of the information that you're learning from the muscle's name. Memorize the name, and then also be sure you're able to identify the muscle when you're looking at a picture, an illustration, or a picture of a cadaver. And if you, some of you guys, if you have the ability, the luxury of working with cadavers in the lab, be sure to go and identify these muscles on the cadaver. The next thing you want to do is again make sure you know the insertions and the origins of the muscle, and then you want to look at the action that it has. So the easiest thing to do is this. First of all, memorize the name. Okay, after you memorize the name, make sure you're looking at the muscle as well as you're memorizing it. Next, what you want to do is find it on your body and then manipulate that muscle if possible. So if you're looking at the biceps, which is again a classic example. First of all, memorize the name biceps brachii, okay, and then triceps brachii. Now, go and touch it on yourself, on your body. Now, when you palpate this muscle, now see what movement does it. So, what do you do? Make it contract. So, when you contract, notice what happens. Which other bone it's moving. So then this way you see it on your body and you've practiced it. So it's going to help reinforce the muscle that you've learned, its action. Um, so this is one of the best ways that you can learn. The other thing is make sure you say it out loud. When you talking it out, you tend to remember more. And then again, remember, while you're talking it out, make sure you're looking at your body and you're identifying yourself. This is probably the best thing you can do. So yeah, relate the muscle's location or attachments to his actions. Um, and then read the descriptions in the table and then identify the muscles on the figure. So the tables that are in the book, they're quite well, so be sure to use those. And then, look at it on the table and then look at it in a figure. After you look at it in a figure, then try to identify it on your body as well. And then remember, again, say it out loud. It'll help you a lot. Palpate these muscles on your body also. So here's some of the major muscles that we may be looking at as you go through. So these are some of the muscles. These are the muscles of the anterior of the body, and then these are the muscles in the posterior of the body. So the first group of muscles that we're going to be looking at are the muscles of the head, and these are the first part one, is going to be focusing on facial expressions. So the facial expression muscles, they're different because they insert into the skin, okay, not into the bone. Now, this is very important in nonverbal communication. So think of all the times, if when you're upset and what do? Or when you're scared or when you're excited, all these expressions, they're able to, these facial expressions, they're able to communicate how you're feeling. Um, Now, the other thing that's very interesting about these, the muscles that make up your face, they're all innervated by cranial nerve 7, okay, which is the facial nerve. Now, facial expression muscles, they consist of two groups, muscles of the scalp and muscles of the face. So let's start off by looking at the muscles of the scalp. So the first muscle we're going to be looking at is this epicranius muscle. It's also known as the occipital frontalis. So the description of this is it's a bipartite muscle that's made up of the frontal belly that you see over here and the occipital belly, and it's connected by the cranial epineurosis. And you can see it right over here. This is the epicranial, the epineurosis over here. Um, Also, in addition to that, the Galea aponeurotica, which you're not able to see over here in this image, and the alternate actions of these two muscles, they pull the scalp forward and backwards. So now when you look at this, the frontal belly, it covers your forehead and the dome of the skull, and its insertion are the skin of the eyebrows and the root of the nose. And the origin is the Galea aponeurotica. So with the aponeurosis fixed, this muscle, the frontal belly, it's going to raise your eyebrows. So, kind of like when you're surprised, the way that your eyebrows go up, this is this frontal belly, the belly that's doing this. In addition to that, it also wrinkles your forehead, the skin of your forehead horizontally. Now, the other muscle, the occipital belly over here, its origin is the occipital and the temporal bones. In addition to that, the insertion is the Galea aponeurotica. Now, we cannot see in this picture over here. Maybe there's going to be another picture that we'll be able to look at it in. But now, as far as the action that this the occipital belly does, is that it fixes the aponeurosis and it pulls the scalp posteriorly. The next thing we're going to be looking at is the corrugator supercilii, and this is this muscle over here. It's behind the orbicularis oculi. So this is a small muscle, and its activities are associated with the orbicularis oculi. The origin is the arch of the frontal bone, which is above the nasal bone over there, and then the insertion is the skin of the eyebrow. Now, what does it do? The action, it draws your eyebrows together and inferiorly. So this is the prime movement. This is the agonist. In addition to that, it also wrinkles the skin of your forehead vertically. Okay, so when you're frowning, I want to see what we can look at now. Right over here, this is your orbicularis oculi. Okay, this is the left side. This is the left orbicularis oculi, and let me see if I can move this out of the way. All right, very good. So when I move this out of the way, oh, I went in too much. And right over here, I need to pull this out of the way also. Hold on, let's see if I go over here, click this, and I click this out of the way. There we go. So now you can see this the corrugator supercilii. And so this is the left precarious. See if you can move this out of the way as well. Okay, it doesn't make a difference. Anyways, so there you go. That's your corrugator supercilii over here. So remember, this muscle, it draws your eyebrows together, okay, and inferiorly. And let's go. Okay, there you go. Move over here. So this is your the frontal belly of the epicranius muscle, and let's see if you can move this around. It's your occipital belly over here. You can see, and as you go, oh, hold on, let's not do that. Yeah, okay. Didn't want to do that, but all right, I got that out of the way. There you go. It's back in place now. So yeah, these are the three muscles that we're going to be looking at over here. The frontal belly, occipital belly, and the corrugator supercilii. Now let's move on to the next group of muscles. Now we're going to be continuing with the muscles of facial expression. So the next muscle we're going to be looking at is this muscle here, this orbicularis oculi. So this is a thin tripartite sphincter muscle of your eyelid. It surrounds the rim of your orbit, and its insertion is the tissue of the eyelid, and the origin is the frontal and maxillary bones. Okay, so it's part of the maxilla over there, and then the part of the frontal bone over here superiorly. It's for the prime action this has is that it closes your eyes. Various parts that can be activated individually. So it can also produce blinking movements. For you can use this muscle also allows you to squint, and also it allows you to draw your eyes inferiorly. The next muscle is the right here, the zygomaticus muscles. Zygomaticus, it consists of your zygomaticus major and zygomaticus minor. So these muscle pairs, they extend diagonally from your cheekbone to the corner of your mouth. And the origin is the zygomatic bone. And let's see if you can see here. So here, there you go. See, this is your minor and the major. The larger one is the major, it's the minor. So the origin is the zygomatic bone, and its insertion is going to be the skin and muscles at the corners of your mouth. So again, it's a little bit hard to see, but there you go. It kind of comes over here towards the corner. Um, and right over here, you have this orbicularis oris muscle. So again, this is another uh, muscle that we talked about this muscle. So remember, these are these we had the fascicles arranged in a circular concentric rings. So we have this orbicularis oris, and then also the orbicularis oculi. Now going back over here to the zygomaticus. Um, so yeah, this muscle, the zygomaticus, it is the muscle that allows you to smile. This is your smiling muscle. So it raises the lateral corners of your mouth upwards. Okay, so again, it's going to raise these upwards, and then it allows you to smile. So the zygomaticus is your smiling muscle. The next one we're going to be looking at is the levator labii superioris. And this is right over here, the levator labii superioris. And this muscle, it's a thin muscle between the orbicularis oris and the inferior eye margin, right over there. Okay, so orbicularis oris is here, and the eye margin is here. And the origin is the zygomatic bone and the inferior orbital margin of your maxilla. And the insertion for this is going to be the skin and muscles of your upper lip. And this levator labii superioris allows you to open your lips, so it raises the furrow of the upper lip. Okay. And then we have the depressor labii inferioris. So if you have a levator, then there's also going to be a depressor. So there goes your depressor labii inferioris. And this muscle, so this is going to be and so think of it this way. These are these two muscles. They're going to have the opposite uh, effect. So you have an agonist and an antagonist. Now the depressor labii inferioris, this one, it draws your lips inferiorly. So again, so kind of like when you're pouting. And then the opposite one, it opens your lips. It raises the fur of your lips up. That's going to be your levator labii superioris. So the depressor labii inferioris, uh, this muscle, its insertion is the skin and muscles of the lower lip, and the origin is going to be the body of the mandible, and lateral to its midline. So here's the body of the mandible over here, and then the midline's over here. Okay, so it's lateral to the midline. And we already talked about its function, that it draws the lips inferiorly. And next, let's go to the depressor anguli oris. So the depressor anguli oris is right over here. Okay, depressor anguli oris. So that's the next muscle. And this muscle, it's again, this is a small lateral to the depressor labii inferioris, and the origin is the body of the mandible below the incisors. So incisors is your teeth. So the teeth that's right in your front, the two free teeth that you have in the midline of your mouth are these incisors. So you have two in the top, two in the bottom. So this muscle, it draws the corners of your mouth downwards and laterally. So it's a zygomaticus antagonist. The next muscle we're going to be looking at is this orbicularis oris muscle. Okay, the orbicularis oris, it closes your lip. That's the primary function of this muscle. So again, well, when you're pursing and protruding your lips, the kissing and whistling muscles also. This is what it's known as. So the origin arises indirectly from the maxilla and mandible. The fibers that blend with the fibers of other facial muscles associated with the lips. The insertion encircles the mouth and inserts into the muscles at the skin at the angle of the mouth. Okay. Now the next thing we're going to be looking at is the mentalis. The mentalis is located right over here, and this is insertion is the skin of the chin, and the origin is the mandible below the incisors. And this muscle, its main movement is that it wrinkles your chin, so it protrudes your lower lips. Uh, the next thing we're going to be looking at is the buccinator muscle. Okay, it's right over here. Um, this is a thin, it's a horizontal cheek muscle, and it's the principal muscle of the cheek. It's deep to the masseter. The origin is the molar region of the maxilla and mandible, and the insertion is the orbicularis oris. And this muscle, it compresses your cheek. So when you're sucking in or when you're whistling, this is the muscle that's allowing for this action to happen. It also holds food between the teeth during chewing, and it draws the corners of the mouth laterally. So it's a very well developed muscle in nursing infants. The next thing we're going to be looking at is this big muscle here. This is called the platysma, and this is an unpaired, thin, sheet-like superficial neck muscle. And the insertion is the lower margin of the mandible. Okay, you can see over here, this is the lower margin of the mandible, and the skin of the muscles at the corner of the mouth. The origin is the fascia of the chest over the pectoralis muscle and the deltoids. Now, this tenses the skin of the neck. This is what this muscle does. So, for example, when you're shaving, and you kind of tense the skin of your neck to be able to shave that area underneath your mandible nicely and evenly. It also helps depress the mandible. It pulls the lower lips back and down. So again, it produces this downward sag of the mouth. Now, all these muscles that we've talked about so far, including the last slide that we looked at, uh, these are all innervated by facial nerve. Okay, so cranial nerve number 7. I forgot to mention, which I should have said it along with the zygomaticus, is this muscle that's right over here. This is which is called the rhizorius muscle. This is a slender muscle that's inferior and lateral to the zygomaticus, and its insertion is the skin at the angle of the mouth, and the origin is the lateral fascia associated with the masseter muscle, and this draws the corners of your lips laterally. So it tenses the lips, and it's a synergist of the zygomaticus. So again, very easy to remember. If you look at the zygomaticus muscle, think of that as your smiling muscle. Your orbicularis oris muscle, this is the puckering muscle or the kissing muscle. The mentalis muscle, this is the muscle that you're pouting with. Okay, and remember, this is the mental part of your chin. Uh, and the platysma muscle, this is your shaving muscle. So when you tense up your neck when you're shaving, then let's go down over here. This corrugator supercilii muscle. This is the muscles that are right over there, and this is the kind of, I guess here, like they say, the angry eyebrow muscle. And the orbicularis oculi. This is the muscle that closes your eyes and the muscle that you use to blink. And the frontal belly of the epicranius. This is the muscle that's raising your eyebrows, and it causes your forehead to wrinkle horizontally. So let's continue with looking at some of these muscles that we talked about in this 3D model that we have here. So right over here, this is the left masseter muscle, and although we didn't talk about it, this is one of the chewing muscles. But what we can look at, the reason we want to look at this left masseter muscle is because uh, this left masseter muscle, it serves as an origin for this rhizorius muscle. So this is this rhizorius muscle right over here. So remember what we said, the lateral fascia that's associated with the masseter muscle is the origin. And then the insertion for this rhizorius muscle was the skin at the angle of the mouth. So if you kind of move this out of the way, you really can't see it. Let me see, I'm going to try one more thing. You can't really see what's... Yeah, you can't really see it over here. Oh, here. There you go. Now you, well, you kind of... Yeah, you can't really see it. But here's the left rhizoras over here. Now let's just go from the top. We'll look at this orbicularis oculi. Okay, so this is the left orbicularis oculi muscle over here. And I'm going to move this out of the way. And then I'm going to rotate this a little bit so we can look at it. There we go. Here we can locate it, rotate it here as well. So yeah, this is your left, that was your left orbicularis oculi. And then let's look at your smiling muscle, your zygomaticus muscle. And remember what you said about the zygomaticus muscle? It had two parts to it. There was a zygomaticus minor and a zygomaticus major. So let's look at, let's find those over here now. This is your minor, and I can rotate this. There you go. Right, so this is the minor over here, the zygomaticus minor, and this is the zygomaticus major over here. So keep in mind the origin and insertions. So the origin is going to be the zygomatic bone. You can't see it over here. I wonder if I can show the bones over here. But anyways, I'm not going to go further with that right now. But yeah, so here you have your left your zygomaticus major, this left zygomaticus minor, and remember this is your smiling muscle. This is the muscle that allows you to smile. So it's moving the lateral corners of your mouth upwards. We looked at the rhizoras, orbicularis oculi. We looked at this muscle. So again, the insertion for this is going to be the tissue, the eyelids, and the origin is going to be the frontal and maxillary bones and ligaments. So if we rotate this over here, so you can see over here, so how this muscle, it kind of, it's, this is your maxillary bone is going to be over here, and this is the frontal bone over here. So this kind of goes over both the bones. So this is the origin for it. Then as you move along, then you go to the levator labii superioris, and let's locate that now. So right over here we have your left levator labii superioris muscle. And remember what we talked about this muscle. The origin is going to be the zygomatic bone and the infraorbital margin of the maxilla, which you can't see over here. And the insertion is going to be the skin and muscles of your upper lip. So here you can see again, this is your upper lip over here, the orbicularis oris is going to be inserting over here. And let's go down to, since we're looking at this, let's just go to this orbicularis oris now. So this is this huge muscle over here, your orbicularis oris muscle. And again, we talked about its insertion. It encircles the mouth. It inserts into the muscles at the skin of the angle of the mouth. And the origin, again, it arises indirectly from the maxilla and the mandible that we talked about. And so let's see what else. So we talked about the orbicularis oris. We looked at the left, the levator labii superioris. And so if we talked about that, let's go to the depressor labii inferioris. Let's go over there. And right over here, this is your left depressor labii inferioris. So remember, this muscle is going to allow you to draw your lips lower. So like, when you're pouting, so it moves your lips inferiorly. And it inserts at the skin and the muscles of the lower lip, and the origin is the body of the mandible lateral to its midline. So again, you can see that over here. What else could we do? Let's see. Now we can look at the depressor anguli oris. So this is, I'm not sure if we looked at it, but here, this is the left depressor anguli oris. And so this muscle, again, muscle, it draws the corners of your mouth downwards and laterally. And listen, this is the zygomaticus, it's the antagonist of the zygomaticus. And its insertion is the skin and muscles at the angle of the mouth below the insertion of zygomaticus, and the origin is the body of the mandible below the incisors. So again, what else could we see over here? Did you look at this? So this is the mentalis over here. Yeah, I don't think we mentioned this yet, but the mentalis, again, this wrinkles your chin. This is the muscle that makes your protrudes your lower lips. And again, the insertion is the skin of the chin, and the origin is the mandible below the incisor. So right over here, you'd find your incisors. And then what else do we have? We can see here. This is your platysma right over here, guys. Okay. So again, this is the muscle that you're tensing up when you're shaving, your face, the area underneath your jaw. And did we look at the? Let's see. Move this back out of the way. Remove this out of the way. I'm gonna move this out of the way over here. Move that out of the way over there. I want to turn this over here, and then we need to look at the buccinator, and the buccinator should be right over there over here. So if we move this out of the let me move this out of the way so you can take a better look at this muscle. There you go. So right here, this is your buccinator over here, the left buccinator. So remember, this muscle, it compresses the cheek. So again, when you're whistling, and then the sucking muscle. So the origin is the molar region of the maxilla and the mandible, and the insertion is the orbicularis oris. So can we see it inserted into the orbicularis oris, I wonder? This is the second time I'm using this this software. So I highly recommend, if you guys, especially if you don't have a cadaver, that you go on and if you work with this this model, it'll be a wonderful help for you. So let me start peeling some of these things away, and then you can kind of see better what's going on. So remember, this is the muscle that we want to look at, the left buccinator. We want to see its insertion. So let's move this out of the way. I think I just moved. Yeah, I just moved it out of the way. So, so much for that. But yeah, here you go, guys. So you can see that this muscle, it inserts over here to the orbicularis oris. Look at the mentalis. We looked at the platysma. Talked about the orbicularis oris. So I think we covered just about everything that we talked about. So yeah, you might want to come over here to this website and look at it. This is the so here, this is the URL for it. If you go online and you Google 3D Netter's 3D Anatomy Atlas, you should be able to find it. Land to this page as well. And we're going to be using this. I think I might be using this a lot more as we go through. This will come in handy. But there's a lot of muscles over here. This is the most dense area of your body with muscles. And again, you have this small area, which is your head, and there's so much going on. Again, the muscles that you're using for expression, the muscles that you're using for chewing. So it's actually, when you're working with cadavers, when I work with cadavers, this is the part that I found most challenging. Just because, again, you have a lot of the muscles that are so small, and then just because everything's just so congested, you have to be very careful when you're working over here. Same thing with the eye muscles. When you get to this part, I'm not sure if you're going to be looking at it, but with these muscles also, you have to be very careful when you're working with. Depending on your college that you're going to, you might be working on a cat, for example, when you're doing cat dissections. Again, when you come to the to the head and trying to look at these muscles, it's quite challenging. I was fortunate enough to work with both a cat as well as the human cadavers. All right, so I'm going to be stopping over there at that last slide. If you go to the next part, Chapter 10, Part B, you'll find the link for it in the description below. Also, you can see it in the playlist. The reason I did that, I explained why, but the lecture got too long to make a long story short. Anyways, if you have any questions from this lecture, please be sure to email me, or you could leave it in the comments below. If you like it, please give it a thumbs up, and please be sure to subscribe. And when the new lectures are loaded, you guys will get alerted for that. Thank you so much for watching.